No, it's an incomer for 11 kV.
11 kV
11
incomer,
side.
AC,
Yeah,
yeah?
because, yeah, 11 kV side.
Okay.
But you cannot operate it during the during energies condition.
Energies condition.
Because
Okay.
vehicle need to be open and you have to wait until, because there is indication like this here. And here it is, there is interlock. Interlock is there for operating this isolator switch.
Okay.
Interlock means you need to rack out the breaker.
Breaker.
If not rack out, you cannot operate this one.
That means MV switch
Every
gave
switch
into
here you need to
rack out.
Yes, rack out. Rack out.
Interlock is there.
Interlock is there to
when
open.
you rack out, you will get, there is an indication you will get. There is an indicator.
Yellow.
Yes, the ground. Okay, fine.
When it is high, only you can operate this switch. Otherwise, you don't operate, because if you operate wrongly, that switch, the isolator will get stuck. So it's another reason. And here you can see there will be input and output cable. Both are coming into this cabinet only.
Cabinet.
Input and output.
Okay.
So input will be here, output will be here. Okay. So here the cable entry from the downside. So
Okay.
it is connected like this. So then inside the module you can see there is a internal transformer is there, that is converting 11 kV to 3.3 kV. So here is a transformer. You can see the transformer.
So one question now, this transformer has a ventilation, correct?
Yeah.
Is there any parameters to be maintained for this temperature inside? Like example, if the room getting overheat,
There is a settings actually.
there is a setting, so this VFD will trip
Yes,
also
yes,
if
yes.
in case of
the
any
temperature.
overheat.
Yes, yes. Because it is, the drive is monitoring the temperature from the transformer also.
Mm.
Yeah. Transformer side and inverter side differently it is reading.
So okay. So Yunus, we need to think about backup cooling system, okay, for this room. Otherwise, you will have also due to insufficient cooling, you will get trip. Huh?
What is the maximum temperature required for this machine?
At least you can keep 22.
22 we are maintaining now.
22.
22.
It's a maximum or it's a minimum?
No,
The maximum 22.
Maximum 22.
it can go like
Your alarm temperature set point. What is your alarm?
that I need to check.
Okay.
That I need to
Just
check.
take a note. What is the alarm set point? Then you can.
Is there any backup cooling for this one or no? There is no backup
Here,
cooling.
this room.
Yes.
Shahid,
18 to 22. 18 to 22 we are maintaining here. 18 to 22.
AHUs only.
3 HV.
So duty standby or all duty?
Two duty, one stand.
2 duty, 1 standby. Okay. So we have a standby.
For this room we are maintaining 18 to 22 degrees.
18 to 22.
2 duty, 1 stand.
Yes,
filter
two duty,
also.
one
We
stand.
haven't seen
Yeah,
stand.
filter here.
They are
Here
saying
is a
everything is
filter,
running.
and then
ये
the
कचरा कौन सी का? इरफान?
also on the filter.
ये फिल्टर के बारे में
Yeah,
बराबर
where?
बराबर
Where?
देखो
I'll show you.
कैसे फिल्टर चेंज
This
करते
area filter and
Okay.
this area.
So how to clean the filter?
I'll show you inside how to remove it. I'll just show you how to remove it.
And weekly basis.
No, you can clean in 3 months for 6 months, something like that. It depends if there is no dust, because you need to keep clean the room all the way.
Okay.
And after this you have a transformer, and we have here the thyristor diode, 24 parts thyristor diodes are there. Input here.
Thyristor?
Thyristor diode. It will convert AC to DC. So DC, and we have here like IGC, protection IGCTs. So any short circuit in the DC side, it will open. It will protect. It is more faster than 100 times faster than the fuse units. So we have these components mainly here, and some resistors and bottom bars. Whenever doing any PM jobs, I can show you whatever inside physically. And this side we have IGCTs and capacitors. Output capacitor and DC capacitors are here, and this area. And this is the inverter unit. And behind this there is a output sine filter choke also is there. So that's inside. You cannot see from here. From the back side you can see that. And this is a circuit diagram. You can from this one. See, this is the thyristor diode parts. This is the thyristor diode parts. And this is the DC protection IGCTs.
1 second. This is the
Thyristor diode.
protection
Protection
IGCT.
IGCTs. Protection
Okay.
IGCTs.
And this one for thyristor.
Yeah, thyristor. We convert it to DC. In the DC lane, we have a protection IGCTs. So any short circuit here, this will open. because it's instead of fuse unit, we are installed the IGC protection IGCT here, and we have a inverter section is here in this side. So this is the general structure of this drive, and here we have two types of drive. One is with the external transformer, extension transformer. There's two transformer in the same drive. So both are coming from the same breaker. Same breaker, the supply is coming, 11 kV is coming. One is coming to inside the drive, it will convert 11 kV to 3.3 kV, and another is going to the auxiliary transformer. It is converting 11 kV to 450 volt. In that drive, from the same transformer, we are taking auxiliary supply for the drive, three-phase auxiliary supply. That auxiliary supply we use for the fan and the control circuit. So, in other, the small drives, we are getting the three-phase from external. You are providing three-phase supply and single-phase supply.
5 and 6 still.
5 and 6, you are giving three-phase external supply because there are no 415 volt transformer. So that you need to be in mind. You need to, because that circuit should not be tripped in any case. So if it is tripped, you will get a control supply loss code.
That supply through the UPS. But now
Now-
5 and 6 through the UPS.
No.
ABB people are here.
For chiller, for control circuit we have UPS.
For VFD control, we have a UPS.
Yeah, UPS.
For chiller, the three-phase supply,
No UPS.
No.
Yeah, that you have to check.
That's
Yeah, I will
directly
check,
from the breaker only.
from the breaker.
Because first of
Chiller
all,
5
there
and
is no
6.
any
5 and 6, the
voltage is
small one.
okay, everything is okay, water is there, everything.
This one, why we are converting DC and DC to AC?
Because
AC
you
noise,
cannot,
AC supply is
because
okay.
the switching, through the switching only we can control the
From a
speed,
side.
we can vary the frequency and all. We cannot directly do that.
Frequency
Because
in
it
AC.
depends on the switching speed.
ಡೀಸೆಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರೋದಲ್ಲ ಹರ್ಟ್ಸ್
Eight panel for the 8 chiller.
Here we are not controlling any
Online
speed
check,
to
because it will be in
the
the-
chiller, right? We are only step down from 11 kV to
I will
4
come
kV.
and there. I will
6
come.
kV.
6 kV
6 kV to 4 kV.
thermistor from 4 kV
From
Thyristor,
But we are not doing any variation on the feed. In the chiller, it will be constant speed only. Constant voltage, constant
From
speed.
VFD it is going directly.
Directly. There is no changes in the field. So this VFD mainly from 11 kV to 6 kV, 6 kV to 4 kV.
4
then
kV to direct to chiller.
ಚಿಲ್ಲರ್
So these are the capacitors inside the drive. Usually this we will change by 9 years. Should be.
9 years.
Every 9 years should be changed.
Yeah. And
But
every
during
day,
PPM, you
So this one installed from which year? This one now?
2021.
2021, yeah, 2030.
5 years.
5 years still.
Actually, every time, because when the contract is live, we do annually PM. So during that time, we inspect the capacitor. We will disconnect the terminal. We will measure, and usually we record everything.
ಆಲ್ಮೋಸ್ಟ್ ದೇ ಆರ್
You
ಟೆಲಿಂಗ್
will
9
will know
years
the health
But
status
when
of
coming
the
7, 8 years,
capacitor. So
What's the
any
time to
budding or
replace?
something, we need to replace.
Yeah, we need to replace it. So my question is this capacitor, how many capacitor inside this VFD?
There is 4 capacitors.
4 capacitors.
Each
For
four
huh?
capacitor.
Okay.
Because it's like oil, different oil filled capacitor. There is some liquid inside that. So whenever you doing like a PM activity, any like you are replacing the filter or something, you need to switch off the drive for the safety reason. Because all the time, just open the breaker and do any PM. Like you are not going to open the door because in this drive you will not, you are not able to, you will not be able to open the door until
Switch off.
down this
Switch off.
Otherwise it is interlocked. You cannot open the doors. And if door is not properly closing, you cannot operate the isolator switch also. So these things, yeah. But anyway, whenever you have issue, you can call ABB and we will give you some.
this capacitor, you said 4, right?
Yes.
As in the drawing, it is only 2.
Two.
For the filtering purpose, 2. right?
There's a 4 capacitors, AC and DC capacitor.
Okay. 2 for filtering purpose, 2 for
DC. And actually, we are actually planned for the operation and maintenance. I don't have much things in here to show you. Inside the drive. So if the pressure is high, drive will be tripped. If the pressure is low, also drive will be tripped. It's based on the filter cleaning or filter presence. If you remove the filter, there is a pressure loss will happen and the drive can be tripped. And if it is that's what if you during running you don't do any kind of these activities and do with
Should be off.
yeah,
and
should be open
clean,
the breaker,
turn
yeah,
back and
yeah,
run.
Yeah. Then there is a control supply there, but anyway, the control supply, if you disturb the control supply, it will give the trip in the switch gear. And one more thing, all protection for the drive is breaker, main breaker. Any fault in the drive, it will operate the breaker only.
There is two relay, one chiller tripper, other is VFD trip.
On the MV switch gear.
Because in that drive there is a two kind of fault is there, class 1 and class 2. Class 1 means that is a major fault. It will directly trip the breaker. So breaker will be open. And class 2 is like it will stop the motor. It will disturb the motor. Class 2 will be like your emergency stop and any customer interlocks is there. So in this case it will trip on the class 2. Class 2 just stop the motor only. So it will not open the breaker. Sorry, emergency also class 1 because it will open the breaker. So any other kind of interlock, it will only stop the motor. So this you need to see. And another thing you need to always make sure on the battery backup or the breakers, because breaker will work out depend on the supply. If supply lows, drive not prepare the breaker. So that things you need to
No, which battery you need to say?
in the breaker.
In the breaker itself.
Breaker or UPS
not the
supply.
UPS.
No, breaker
Okay,
UPS supply.
breaker.
Because that's I just explained the safety.
Okay.
Because that always need to be.
We can check the status in this panel, right? Battery status.
No. That's your side.
No, not this side. As you said, in the VFD drive, you have a battery, right?
We have battery in the drive. That is for the control backup for the drive only.
Drive only.
That battery will stay for 15 minutes only.
Okay.
So after that, because anyway that time itself drive start with the alarm, this control supply low. So after 15 minutes it will shut down the drive.
Shut down the battery. You said which battery we need to
Which
monitor?
battery for the
No,
breaker?
in the UPS supply in the breaker. UPS supply for the HV breaker.
HV breaker.
This UPS which?
This UPS, the one feeding the VFD or
No, for
which
the-
UPS?
No, I am telling about the breaker. You are providing supply to the breaker.
MV switch gear.
Battery charger.
Battery
Battery
charger.
charger. The one highlighted by QGC, battery charger Kharban, huh?
That you always need to monitor all functions of it. Because-
Okay, I have one question.
Yeah.
In case chiller fail, auto operation of chiller is fail.
Okay.
So we are going to run the chiller on the manual basis. So we
From-
have to operate this one also manually.
Manual means.
Suppose
Oh,
chiller
this
is not
one no
working
relation,
on
this
auto.
one.
So start command, you cannot give start command from DCS, right? That case.
No.
See. The question is that suppose chiller is right now working on auto mode. Okay.
Okay.
Automatically it is controlled from the SCADA. In case the SCADA fails, chiller is not running in auto. We are going to run the chiller on the manual basis.
Okay.
So this also need to be run
We
manually.
can run in manual now because from the control board itself we can make it local.
Hmm.
Then you can give the reference and you can
Okay.
start it.
So if SCADA, example, totally lost in the
we
building,
can run. Yes.
we need to run the chillers.
Yes.
Chiller, the operator there, he will make it in manual mode, no issue. But I'm talking about here also
Supply.
to run each VFD interlocked with one chiller, or you can or it doesn't matter. You can run.
We can make it local and we can run it.
You can run it.
There is a provision for running in manual.
So
also.
auto also we can run it.
Auto means when we put in the auto mode from the drive side, it will be auto control only. That is
No, if the chiller is in the manual mode and from here it can run in the auto mode. or
auto
no?
mode, yeah, because our drive will behave depends upon the your start command, start commands, no start input commands. That's it.
BMS in the building. Maybe sometimes you want to run the VFD again. You need to reset from BMS. Sometimes you cannot run in the field when you put in auto mode. So
there is
here
no
the same
intermediate.
example. Okay, when you put it here manual mode, what parameters you will put in the screen? We need to ask him how to run it.